Hello everybody! Today we are going to talk about preprocessor directives and multi-file project. Well, first let's talk why should we create more than one file. Imagine a situation like that. Your program is a bit longer, and again longer. Many times than this guy. So your program is about, for example, 1000 lines, right? There is much code in it. And then you are deciding, hey, I have to change something here. Then I'm making the change, and then I have to what? I have to compile that program, right? And that compilation will take lots of time because your program is longer now, right? So it is taking time of to compile something like that. And imagine now a situation like that. We have many files. So now I am dividing 1000 line of code into, for example, 5 files, and then when I change something in one of that file, we have to compile only one of that file that is changed. So we don't need to compile all the code again. So our program will run will compile faster, right? So we are saving time because of that. That's the one of the reason. And the second reason is that our program will be organized because of creating many files, right? It will be organized, and because of that it will be easier to find something in our program. Okay, so now how to create a new file and create a multi-file project. So now I have to create target that source here, then file, then new, then the file, and then the header file here. The header file is something that is used to create libraries. Okay, so I am creating right now the header file. I'm clicking go, then next, and please always remember about clicking here, because later you might have problems with compiling, so remember about that. And now we have to name our file. So I can name it, for example, our first library, then zapisz, which means save, and I will click finish. As you can see, our IDE has created already here some line of code that I will explain you later. And now we should know how does that hash things works. We have already been using something like the preprocessor directives, but we didn't tell about them so much because I think that was too hard topic then. We just say that this is the library that is just included here and we can use later because of it, for example, something like that. But now I will show you that we can go to that code. For example, I can go here, and as you can see, here is some code, and in that code we also do something like that we include something, and in that code we include something and other things like that. Okay, and how does exactly this thing work? Well, it works like that. The preprocessor directives works like that they are executed before compilation because they are preprocessor directives. Okay, so it means that before the compilation, everything here that is looking, for example, like that, is being replaced by, for example, something like that. You'll notice that now when I build and run this program, everything will still work fine. So I could also go into that thing here, into that thing here, and just copy and paste that thing. But of course, that thing would be bad because every time we change something in our program, everything from the beginning would need to be compiled. It will take time. Now, we don't need to compile the thing that is there, right? Okay. The next example is, for example, something like define. Define is something that can define. So we can create something. For example, we can say that I want to, in every place on our program change pi to 3.14. And now I can just do something like that, and before compilation that pi here will be changed to something like that. So now when I build and run that program, as you can see, we have 3.4. Okay, so now we know how does preprocessor directive work, and well, let's, for example, use our first library, right? I will delete this code for a second, and I will do something like int a equals 10 here. And I want to include our first library. In order to do it, we are going to use the quotes, not the angle brackets. Our first library dot h, and now you'll notice that I can use easily that thing here, because it's really that thing here is being replaced by that, right? So let's see, when I build and run the program, as you can see, everything is working fine. What is the difference between that quote signs and angle bracket sign? Well, this thing here is really the library that is set in our compiler settings. Okay, it is set in our compiler settings, and the path to it is just absolute, right? The path is known, and we can use something like that when we want to include a file that is next to that file here. So it looks like that our first library .h is next to the main CPP. We should use the quote signs. Okay. And now you have noticed that I removed some code here. That code is really good, that it is created by our IDE, because we normally would need to create it by hand. And as you can see here, there is very similar code. There is something like if, not, define, and then the info. How does it work? Well, you will notice that I can do now here something like that, and something like that might happen by mistake sometimes, or sometimes it's needed. And as you can see, well, it's working still. So we could just copy the code in IOStream many times and everything is working. How is it even possible? When I copy that guy here and I build and run that program, you'll notice that it's not working, because it's telling us that A has already been defined. Well, it's true, because it really looks like that. We can define, so reserve memory for the same variable with the same name, right? So we can do something like that. So how it happened that in our stream it worked? Well, it looks like that. I will just back to that place here, and let's see how does it work. That is the preprocessor, right? So the directive, so it's working before compilation. If something what is called like that is not defined, please define that thing and then just do everything after that until meeting the end if. That end if is like the closing curly bracket. So we are defining that variable here, and that's all. But when I do it about, for example, 3 times, and I build and run that program, it works now, because in the first time when the preprocessor is doing the directive, he is checking if that is not defined, he's defining it, and in the second situation he's checking if it's not defined. Well, it is defined then, so everything from to the end if is not going to be executed at all, right? So that's why that code here is really good. I know that the situation like that probably won't happen, but you might include many libraries in other libraries and things like that, and that mistake might happen, and because of that everything will work fine. So that thing is really good to do something like that here. Okay, now I'd like to tell you about something like the external variable. External variable is variable that should be in other place defined. So this thing is external, outside. It means that here we do not reserve memory for variable a. So 4 bytes are not reserved here at all. We should have the variable defined somewhere else. And there is something what is called also functions, right? And we can create them in libraries. So for example, functions show help, and I can just have here declaration, which is automatically extern. We don't need to add here extern, and we can create it outside of that library here. And it's always being done that way in programming, so that is well organized code. Now we can create, for example, a source code, again, new file, and now I'll choose the C++ source file, go, next, C++ language, of course, and please remember about doing that thing here, tick the debug and release. Then we can call that thing, we'll call it this as the same like our first library, and we'll click save, finish, and here we should just create definition of that thing. So int a 50, and now the function, this is help, right? So for example, like that, and of course the quotes. And now we'll need to also use here namespace std and include the IO stream, so we can use the cout easily. And as you can see, everything works fine. We can now use the function from our first library. So for example, show help here, and everything will work fine. And you might be now asking yourself, why do we do something like that, the 2 files here? Notice that later your code might be a bit longer, and then you just go to the file that is ended with .h to look what you can do here. So here would be just a declaration of function, declaration of variables, and they would be also for example described. So there would be something like, this is going to help you, right? So everything is going to be described here, and you can read about that. But if you need to change something, or you need to know how code works, you will just go to the file that is ended with cpp and just go and look if there is that function, right? And change it if you need it. So it's really now organized file, right? It's really good. You should now notice that we also can, for example, include IO stream here. We could use, for example, namespace here, right? And we wouldn't need including that thing here. everything should work fine. But, well, maybe it's more readable when we do it that way this time. Okay, that's all in the lesson. Thank you very much.